Hi everybody, this video today is going to be talking about lesson 7.4, which is graphing radical functions. In the Big Ideas textbook, that is found in section 5.3, but in our unit it is unit 7, lesson 4. Okay, it says to use your graphing calculator or Desmos to fill in the table and graph. We're just going to go through and do this. So first of all, the parent function, the formatting got messed up. Sorry about that. The parent function is f of x equals the square root of x. Then, as far as the x values go, I put in here perfect squares. The reason I put in perfect squares is they're easy to take the square root of. So that's why I have that. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. So when I go to graph this, it makes this shape. Now, as you look at this shape, you should be thinking some things. A couple things. One thing you might be wondering is, okay, we've talked before about how the square root of 4 could actually be negative 2, couldn't it? And this couldn't be negative 3 and this be negative 4? Well, if you did have those negatives, then you would have this down here. And now, what does that shape look like? Doesn't that look like a sideways parabola? It is a sideways parabola, and it doesn't pass the vertical line test. So I'm going to erase this section because it is not both the positive and negative, it's just the positive values. Otherwise, it would not be a function because it would not pass a vertical line test. Secondly, if it is a parabola, it follows a specific 1, 3, 5 pattern, right? Well, look, this one does also. It goes up 1. Oh, I should go, yeah, I'm going sideways. Up 1 over 1, up 1 over 3, up 1 over 5, and so forth. So it follows the 1, 3, 5 rule, but it's sideways. So this time it's going the other way. Now, domain and range. This is a solid point at the 0, 0. It does not continue on, like I said, this way. It does not continue on over here or anything like that. It just stops there at 0, 0. So when we talk about domain, the domain starts at 0. Remember, domain is our x values, and goes to infinity. And it has a square bracket because there is a point there. Range is our y values. Once again, it starts at 0 and goes all the way to infinity, and it has a square bracket because there is a point there. That is the parent function of the square root of x. Okay, the next question on number 2 says, on the same grid above, plot g of x is equal to x minus 3. What is the transformation? Remember that when it's minus 3 in here, that actually means right 3. So that means we take our graph. Did I go the wrong way? I sure did. We need to go right 3. I went left 3, so let's move this over to the right. All right, so g of x should be over here because it is right 3. If you wanted to plug it in, you could certainly do that. You would have to plug in different values, and we'll get to that in a minute. So for now, let's just say it is right 3 because it's minus 3. The next one says, what would it look like if it is a negative square root of x? Remember, the negative on the outside means it gets reflected over the x-axis. So if I reflect it over the x-axis, it looks like this. If we were going to have both sides of that sideways parabola, then we would have positive and negative. If it was f of x is equal to positive and negative square root of x, that would be both halves of it. But again, that's not a function. It's actually two different functions. So that's why we don't have that. But if we just have the negative version, that's what we have down here. The negative is down here. The positive is up there. And then if we have a 2 on the outside, that means there's going to be a vertical stretch by a factor of 2. Let me show you what that's going to look like. All right, the vertical stretch by a factor of 2 is this green one. If you can see, it's a little bit taller. What has happened was we still follow the 1, 3, 5 rule, but we're going over 1 up 2, and then over 3 up 2, over 5 up 2. So that 2 on the outside has made it twice as tall. All right, in this next section, we're going to be talking about cube roots. So the one up above was square roots. This time it is cube roots. And again, our parent function formatting got messed up, but this is our parent function, the cube root of x. I made a mistake in the table. Can you change your x values to negative 8, negative 1, 0, 1, 8? And the reason I chose those is those are perfect cubes. So the cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. And so if I plot them, this time I have a very different look. It's kind of this S shape. It follows a pattern again, but it's not the same pattern. This time it's going up 1 and then up 7. So from here to here is up 1 and then up 7. And then it does the same pattern in the opposite direction. So that is our parent function for the cube root. And this time when we talk about domain and range, well, this time it goes forever in both directions. So it's negative infinity, positive infinity, and negative infinity to positive infinity in both the domain and range. Okay, this time we have a -3 on the outside with the transformation. If we go outside, that means it's going to go down 3. That's going to look like this. Okay, here's my new function, the g of x, and I've moved everything down 3 units. The next one says, what if the negative is on the inside? If the negative is on the inside, it's going to reflect over the y-axis. And for this function, that's not going to be much different than reflecting over the x-axis, but for many functions it is different. But anyway, this is going to be reflecting over the y-axis. Let me show you what that's going to look like. So I reflected over the y-axis, and now I have this line. This h of x is the y-axis. I just reflected each of those points actually across the y-axis to get them. Next question is, well, what does it look like in this? Well, still the cube root of x. The only new thing is the 1/2 in front. That means a vertical shrink by the 1/2. That means it's going to get much shorter. So let's take a look at that. All right, I don't know if you can see it. My graph is getting kind of busy. It is this line right here. Can you see that it's half as tall? The parent function was the blue one right above it, and this one is half as tall. So instead of going up 1, it only went up 1/2. And then over here, instead of going up 2, it only went up 1. So it's just half as tall. It's a vertical shrink by 1/2. Okay, what does all this mean? Well, it follows the same HIVO rules that we have been following all year long. So on the outside, that little number in the cube just tells you which root it is. So it's just going to tell you, is it going to be a square root function or is it going to be a cube root function? So this is a square root function and this is a cube root function, basically. The number outside, that a, that's going to be a vertical shrink or stretch, and we just saw how it could get taller like this or maybe get a little bit narrower like that. That a in front is going to determine that. Now this one inside, we are not going to pay much attention to in this class. You'll do it more next year. But 1 over d is going to be a horizontal stretch or shrink. Don't worry about it. Inside here, that is horizontal. Remember HIVO. Horizontal inside, a vertical outside. So if it's inside, that's a horizontal translation. That means it's going to move, I said up or down. That's not, it's left or right. So inside there is going to be left or right. It's minus, so it's opposite how you think it should be. And then the plus c on the end, that's going to be a vertical translation, going up or down. It's outside the square root. Outside means vertical, so that's up and down. Okay, let's turn the page and we'll look at some more examples.